Good morning, students. Welcome back to the Science 1 class. As we are discussing about electric charge and electric current, in the previous class we have discussed about what is electric charge. Then we have discussed electric force. That is, the force exists between the charges are called electric force. Then we have discussed electric field and then potential, electric potential, and the last topic in the previous class about electric current. And today we are going to discuss about electromotive force, that is EMF. Imagine that the two ends of the water pipe is filled with water and they are connected. Now tell me whether the water will flow through the pipe by its own? No, it's not possible. So when you insert a pump in between, what happens? The pump pushes the water so that water flows through the tube. Flowing water or moving water, it can be used to do some work. Similarly, let us take a copper wire. So the copper wire is full of free electrons, but the electrons are not moving in a particular direction. So we need a device to make the electrons to move in a particular direction. So in a circuit, we use cell or battery which pushes the electrons to move in a particular direction. So, the pumping action of the electrical energy source is made possible by electromotive force. So, in the case of water system, the pump pushes the water so that the water starts flowing in the tube. In electrical network, the battery pushes the electrons so that the electron starts flowing in a wire or conductor. So, when the electron starts flowing, what is produced there? Current is produced. So, we can say battery is analogous to water pump. The pumping action of the electrical energy source is made possible by electromotive force. So EMF is denoted by the letter epsilon. The formula of electromotive force is epsilon is equal to work done by charge. Epsilon is equal to W by Q. EMF of an electrical energy source is work done by the source. Here source is battery in devising unit charge Q around the complete circuit. The SI unit of EMF is, as we know, the formula for EMF, that is work done by charge. W is what? W is the work done. Work done is measured in joules. It is denoted by the letter J. Q is the electric charge and it is denoted by the letter Q, and the SI unit of electric charge coulomb. So we can write the SI unit of EMF is joule per coulomb, that is J C power minus 1 or volt. So SI unit of EMF is volt. So how can we define 1 volt? The EMF on electrical energy source is 1 volt of 1 joule of work done is by the source to move 1 coulomb of charge completely around the circuit. This is about electromotive force. Next topic is about potential difference. So far we have discussed the flow of electric charge or flow of electrons constitute electric current. Here we are going to see what causes the charge to flow. Let me give you examples. A ball which is placed on the top of the slope. So the ball does not move on its own. When you apply some force on the ball starts moving. Similarly, in case of charges also, the charge do not move on its own. We need to apply some force. Example number 2. A hot cup of coffee which is placed on a table. After some time, the coffee becomes cold. It is because the heat energy transfer from a region of higher temperature to the region of lower temperature. So due to temperature difference, the heat energy starts flowing. Similarly, in case of copper wire, there are free electrons when there is a potential difference between the ends of the conductor. So the charges start flowing from a region of higher potential to a region of lower potential. So which device produces the potential difference? So the potential difference is produced by the battery or combination of cell. We know a cell is a device which converts chemical energy into electrical energy. Potential difference is denoted by the letter V. And the formula for potential difference V is equal to W by Q. This is the formula for potential difference. A SI unit of potential difference is volt. And which instrument is used to measure the potential difference? Voltmeter is an instrument which is used to measure potential difference. So voltmeter is always connected in parallel to the circuit. So whenever we want to measure the potential difference between the ends of the conductor, you have to connect voltmeter in parallel to the circuit. So the voltmeter has two terminals, that is positive and negative. Red terminal is the positive terminal. It is connected to the positive side of the circuit. And the black terminal is the negative terminal. It is connected to the negative side of the circuit. So the potential difference can be defined as the amount of work done in moving a unit charge from one point into another point against the electric force. And this is the definition for potential difference. We make the simple circuit, we need four main components, that is cell, switch, connecting wire, and then electrical device. So here we have a cell which is connected to a switch and light bulb is there. There or connected by a means of connecting wire. We know the cell provides electrical energy. When switch is on, the bulb glows. It is because the electrical energy is converted into light energy. Instead of bulb, if you place a fan, what type of energy transformation takes place? Electrical energy is converted into mechanical energy, which helps to rotating the fan. Suppose if you place a heating device in the circuit, what happens? The electrical energy converted into heat energy. So certain amount of electrical energy is converted into other forms of energy like light energy, mechanic energy, heat energy, and so on, and depends upon potential different across the ends of the electrical device. So far we have discussed about potential difference and electric current. The scientist named George Simon Ohm, he was a German scientist, and he gave the relation between potential difference and the current. He found when a current passing through a metallic wire increases as we increases the potential difference across its terminal. So the Ohm's law states that V proportional I, that is, steady current I flowing through the conductor is directly proportional to the potential difference across the ends of the conductor. So if we increase this voltage, increases the current will also increases at constant temperature. So Ohm's law states that at constant temperature the steady current I flowing through the conductor is directly proportional to potential difference V across the ends of the conductor. So we can write V proportional I. So we can write, in order to remove the proportional constant, we should add a constant, so V is equal to IR. This is the mathematical expression of Ohm's law. V is potential difference, I denotes the current, R is the resistance. Resistance is the property of a material to resist or oppose the flow of current passing through it. So we can write from Ohm's law, we can derive the formula for resistance. R is equal to V by I. So we can define the resistance of a conductor. The resistance of the conductor is defined as the ratio between potential difference across ends of the conductor and current flowing through it. SI unit of resistance is ohm. It is denoted by this symbol. Metals are good conductors of electricity. All the materials do not have the same resistance. Different materials have different resistance. Metals like copper, silver, aluminum, etc. They have very less resistance, so they allow more amount of current to pass through it. Copper, aluminum metals are used to making electric wires, and they are also used in electric cable industry. If there is resistance less, the current passing through the conductor will more. As we know, resistance inversely proportional to current. If resistance increases, the current will decreases. If resistance decreases, the current flow through the conductor increases. We can control the amount of current flowing through the conductor by using a resistance whenever we draw a circuit, or whenever we make a circuit we use resistance. Why we use resistance? In order to limit the flow of current through the electric circuit. These components are called resistors. Resistors are two types: fixed resistor and variable resistor. Variable resistors are called as rheostat. Fixed resistor has fixed value of resistance, and variable resistance have desirable value of resistance. The next topic is about electric circuit. What is electric circuit? It is conducting closed path or loop which has a network of electrical components through which electrons are able to flow. So whenever we draw an electric circuit, we use the symbols of electrical device. So now we are going to the common symbols in electric circuit. The first one is the switch. When the switch is open, the current does not flow through the circuit. The switch is closed. When the switch is closed, the current flows through the circuit. Second one, symbol for the cell. The longer one line represents the positive terminal. Shorter line represents the negative terminal. So, cell is a device which converts chemical energy into electrical energy. Third one is a symbol for a battery. Battery is a combination of cell or cells in series. Fourth one is the symbol for DC power supply, that is direct current power supply. The next one is symbol for AC power supply, that is alternative current supply. The next symbol of light bulb. Next one, symbol for potentiometer. It is a device used to find the potential difference, electric current and resistance in the circuit. Next symbol, light dependent resistor, LDR, light dependent resistor. So when light falls on this device, the light energy gets converted into electrical energy. Next symbol is the wires joined and the next one is wires crossed. Next symbol for fixed resistor. We know resistor, it is an electrical component which limits the flow of current in an electric circuit. The next one is for variable resistor or rheostat. So it is used to regulate the current without changing the voltage source. And the next one is symbol of fuse. Wire which has low melting point. When huge amount of current flows through the wire start melting and it protects the electrical appliances. Next one is symbol of coil of wire. Next symbol of transformer. So transformer is a device which convert high voltage to low voltage and low voltage to high voltage. And the next one is symbol for semiconductor diode. Diode is an electrical component which allows the current flow in one direction. The next one is galvanometer. Galvanometer is a device. It is used to find the flow of current in an electric circuit. Ammeter, the symbol of ammeter is A. It is an instrument which is used to measure electric current. Voltmeter is an instrument which is used to measure potential difference. Then the next one is two-way switch, which is used to compare the electric circuit. Next one is the symbol of earth connector. The earth connector is a protecting conductor which saves us from electric shock. The next one is symbol for capacitor. It is charge storage device. Then the next one is thermistor. It is a type of resistor whose resistance depends on temperature. And the last one, the symbol of bell. The next topic is about different electrical circuit. There are two types of electric circuit, series circuit and parallel circuit. In series circuit, the components are connected one after the other by a single loop. So the current has only one path to flow through the circuit. So the value of current will be same in series circuit but potential different vary. Next one is parallel circuit. In parallel circuit, the components are connected one by one in two or more loops, so current has different paths to flow through the circuit. So the value of the current differs whereas potential difference remains the same in parallel circuit. So ammeter is connected in series in a circuit, whereas voltmeter is connected in parallel circuit. Next topic is two types of current. One is direct current, another one is alternating current. Direct current, battery is one of the source for the direct current or DC current. This DC is due to the unidirectional flow of electric charge. That is, the electric charge flows in one direction. Then, many electronic devices use DC, that is, direct current. Examples: the device like cell phones, radio, electric keyboard, these all uses DC current. The second type of current is about alternative current. So, alternative current is an electric current which periodically reverse the direction and changes its magnitude continuously with time. So, the domestic supply in the form of AC. So, the device which converts AC to DC is rectifier, and the device which converts DC into AC is inverter. That's all for today's class. Thank you, students. Have a good day.